Okay, so welcome back to the symposium. We're going to have session 2 now. We've got some great speakers in the lineup. We've got the same format as this morning. We'll have 3 presentations and then time for discussion and questions following that. And then we'll have a short break, 2 presentations, and then time for discussion after that. And then Wiley has, the publisher of the AD, has kindly offered us some wine to celebrate the symposium day, so that will happen at about 5:30. So just putting that out there, people can plan their afternoons. So, okay, so we'll start with session 2 now. We've got a presentation from Kasper Jørgensen from 3XN Architects in Denmark. And Kasper contributed one of the texts to the AD. His background is he's an architect and he's a partner at 3XN Architects. And he's also the director of their research and design group, which is called GXN. And founding that internal research and development group as part of the practice, that's something, one of the themes we've been talking about today is this, one of the ways of approaching this challenge of sustainable design is these in-house research and development groups. So we're looking forward to seeing what he'll talk about here. And following Kasper's presentation, we'll have a presentation from Judit, Kimpian, and Derix from AEDAS Architects here in London. And they co-authored an article in the AD. And just tell you a bit more about Judit is the head of sustainability and advanced modeling at AEDAS. And she develops designs that take advantage of computational techniques to maximize sustainable value. So her approach to visualizing and manipulating the spatial, environmental, and financial relationships has provided the basis for a collaboration with the RIBA and CIIB SE to develop the National Carbon Monitor Scheme, Carbon Buzz. And I think that relates to some of the presentations we've talked about earlier today about feedback and actually looking at measured performance as well as design performance. So we're looking forward to that. And the 2 of them together, Judit and Christian, will be speaking, and Derix is the head of AEDAS Architects' Computational Design and Research Group, and he's focusing on computational models for design processes in architecture, with an emphasis on space planning and human occupation. So I think that will work really well with the approach from Kasper to do with user experiences and feedback. And the final presentation in this next session will be from Meredith Davey, an engineer with Atelier 10 Architects, Atelier 10 Engineering here in London. And Meredith Davey he's a chartered engineer and environmentalist with degrees in physics and design art. And he joined Atelier 10 in 2005, and he leads the UK environmental consultancy team. So he's going to bring his expertise in engineering, high-performance design, and sustainability. And he's worked on a number of very exciting big projects, including the Singapore by the Bay project, which is detailed in the issue, which is a fascinating project with a lot of great research. So I'll turn it over to Kasper Jørgensen from 3XN.
All right, thank you very much. All right, so in half an hour I'll try to go through the work and the mindset of the office and our innovation unit, GXN. So as you can see, there's a counter and number of slides in the bottom, so I just keep up the pace. Just talking about the company first. My name is Kasper, and I'm from 3XN Architects. We have been 25 years in business. Obviously, I've only been with the company the past 7 years, 7 years this summer. So the company is working from Copenhagen. And we have a huge stronghold in Denmark, Scandinavia, but also Europe and beyond. Rather small office. We are 80 people. We tend not to grow much bigger. There's physical limitation to that, like the space we work in, but also the size of the organization is one we like to have, so we have a knowledge about who we are and also who the office is. And as you see, we do this is just some building site examples, just to say that in most of our projects, we are challenged in way to problem solving. For example, this is a twin hotel building that we completed last year, and just to see how this very inclined facade has to work with new ways of mounting this. So we actually had to educate mountain climbers in order to find a way to actually have this realization of the concept of having this tilting view leaning towards an open space in Copenhagen. So just, I think this tells two things, that in our work we tend to try to push boundaries, but also that I'm very focused on, fascinated about realizing things and mixing the kind of potential in development, both in material science and in digital development, but also having the focus on realizing it, and that's where it becomes really interesting. So having this kind of continuous pushing the envelope in the projects that we are working with and have been working with, we agreed to start this innovation unit in 2007, where I started. It was pretty much just me. I came from another office, having this kind of strong interest in digital tooling, manufacturing methods, and material science, and now, after a few years, we have grown to become 10 persons. We're like a nice mix of architect, engineers, designers also. Actually, today there's a material psychologist who's starting in our team. So we really like to be some kind of a diverse group, but it's still pretty homogeneous in order to just front the focus areas that we have. So I think maybe the most important thing about the way we work is the way we structure ourselves in our networks. So having this strong professional network is super key in order to be able to qualify the different tasks that we go in and out of. So I'd say that it's kind of a defined strategy to actually have an active professional network that goes out in many directions, and that being all the way out to biologists or scientists or artists, and of course also engineers, other architects. So it's just important for us to kind of break with that tradition of solving everything in-house by the team in the manners that you have kind of grown an experience to do so. We really have to look outwards and integrate other disciplines and other knowledge in order to work the way we do. So we have framed 5 directions, 5 design strategies. These are just 5 quick slides telling what they are. Then later on I will go into one example on each of these examples. So we have the green design, which is very much talking about how sustainability has to be integrated from the beginning of a design process, but also from the understanding of the design scheme. And we have informed design, which is very much about how we inform the design decisions in all the phases of the building process, but very much also in the beginning of the design concept phase. So we're developing small plugins, softwares that can utilize some of this understanding. We work with behavior design. It's been a focus for the companies throughout decades, but has strongly become more in focus the past few years. Having some educational buildings where we really transformed the way you could learn and interact with the kind of physical framework that the building represented. We work with technology design, not just classic design in terms of shape and form, more like taking potentials in green technologies, new materials, and having a focus from the starting point on what is this potential, what is what is a kind of behavior, or the way we could think about product development in integrating these into new building system, building components. For example, here you have this light pole that is generating more energy than it uses, etc. Then the last strategy is experimental design, which is all of them are fun, but this is a fun one to keep engaging into. So in order to be innovative or talk about innovation, we really need to kind of move our own understanding and boundaries for what's achievable. But before I dig into those kind of 5 directions, I'll just have to say that, I mean, this is I've been introduced in the text as a material designer, and I don't know if I am a material designer, but I mean, we are very fascinated with materials, and almost every project we have this focus on trying to think about materiality and material behavior and embedding new material potentials. So talking about our project, we always have this kind of, if you see it as a triangle, we have this design that has been formed with the material potential as much as with the design tools, what's possible in kind of the digital physical interface, and not the least, how do you make this real? How do you go from some kind of digital potential or fantasy or vision to some kind of physical output? And all of this, I mean, talk about innovation in architecture, it's really not necessarily architecture you need to have as a starting point of this observation. So I also brought this project in, definitely not one from the office, but it's a future soldier program. It's from 2000, the US Army had this program that is really pushing innovation. If you talk about material science and a new way to integrate electrical circuit behavior, energy generation, intelligent textiles, this is it. I mean, this is where it starts. And also, I mean, we do look a lot out to observe where do knowledge become mature enough to a level where you can actually start to talk about embedding this into architecture. I mean, just a few examples on this kind of catalog of great materials. You have the exoskeleton, for example, as you see, how you actually are able to carry loads of 150 kilos and still move rather freely. Of course, everything is ballistic textile, so it's, you know, many layers of these strong spectra and Kevlar and carbon fiber textiles, making them bulletproof. On top of that, they have Dragon Shield technology, which actually means when being impacted, it reinforces itself in kind of local areas. If a bullet penetrates, you already get like instant cure from medicine that is embedded into to the textiles. Just saying that this is truly innovative in the what's it called, foot soles of the boots. You have small piezoelectrics, these kind of ceramics. When applied force to, they are generating energy. So it's kind of a self-generating in terms of the energy you need in order to have all this kind of electrical gear up and running. And there are many more. So technology transfer, I think that's key to have an outlook and an insight into what's happening in other technologies. And that can come from automobile industry, it can come from toy industry, from medicine, and that's important to us to not only come to kind of architectural gathering, but also come into context where it's rather rarely you see an architect, and that's really interesting when you get into these kind of crossing of different disciplines and industries. This is actually what got me hooked to have this kind of objective. I was studying in the States, so as a student I was sent out to see this sail manufacturing in Nevada, and I got out, had no clue what I was about to meet, and I saw this guy hovering over this huge sail, and actually he was more like monitoring this robot that is moving on the surface of a huge mold, and you see the yarns being applied to have this kind of optimal structure for these sails. So this is a good example on kind of a digital meets physical world. Previously you did like double curvature from like flat panels that you sew together. You got these kind of shapes and structures, and this invention 3DL makes you able to mold on flexible formwork. You see these scissor lifts, like these huge beds on which you can then apply mylar film and then textiles, and it's what's really interesting is that it's you know, this individual mass production, and it is a shift from going from digital analysis like CFDs to actually foresee the structural needs and performances. You can do that on obviously the sail, but also you can foresee how people are moving on the boat, how the body of the boat is being applied force from the waves breaking in, and all of this. I mean, all of this is being analyzed, visualized, and then also carried out. Very interesting to see how these kind of match race, high-performing boats really represents material innovation, optimization, new production methods, and you see how this slowly kind of gets into to what's achievable or within our kind of economical realm of work. And this image, just to say that it's really what's fascinated me at that time was that because I was kind of lost into digital form development and 3D, 4D, algorithmic design, etc. But it was actually this challenge to translate that into some kind of physical output. I mean, so you have this kind of logical beauty of optimal structures and material design. So that was where I started and where we are today, in the same kind of field of searching, like what is the potential of this digital age, and how do we utilize this? How do the buildings we do, the architecture that we can carry out, how does this get affected, and what are the qualities that we can put into this? Again, just saying it's not really architects or industrial designers. It's in the gaming industry or the movie industry. From Maya, like this software that is really not intended to be dealt with by architects, by a lot of other softwares. Just we have Azam here, who is very knowledgeable about how we actually work with this, and architects have started to play with this. You know, we are now able to like create complexity. All of this that weren't, or at least it was like very hard to approach, is now something that we can start to play with. So what I like about this is we go from having an industrial revolution, the way we kind of think about standardization and mass production, to have this kind of digital liberation. We can talk about more free form, but also higher complexity and individual mass production. So we talk about things that doesn't necessarily need to be inspired by being straight or being standardized. So just an example on our latest project is an aquarium in Copenhagen. It's the national aquarium. It sits right at the airport, and we had this idea of how do people get into this building? How do they kind of submerge themselves into this world of water and the fish, etc., the environment? So we did this kind of spiraling concept in the early stage of the competition, and then we went in a lot of other directions, and actually came back to this kind of geometry and the way that the kind of a wave is breaking over your head while you're kind of entering the aquarium, and it's opening next year. We are completing the building this summer, and then the fish moves in, and half a year later the people can then come and look at them. So having this kind of a short time, I chose not to talk about macro design, which I normally like a lot, talking about micro design is maybe more like this material focus. So what is design in terms of materials, and maybe design where you don't necessarily see this with the human eye, but talk more about like behaviors or material performances. So micro design, I mean, again, classically also very inspired by nature. You have this kind of biomimicry, how you actually are able to observe these effects or behaviors, and this is a classic example of how Velcro was developed for the first spacesuit, but actually just monitoring nature, and we're able to design this. So we're able to design these kind of tangled structures, this kind of micro universe. This is led to an exhibition that we currently have in Copenhagen. It's called Material World, which kind of shows how material innovation is pushing the boundaries of architecture. It runs to the start of June, so after that it might come over here. But the Material World, it's very much saying that, well, also the science, like natural science and biology, chemistry, physics, I mean, if we talk about digital development, it's also affecting the knowledge and the way we work and can control materials. So every 10 months we have a double of the knowledge that we previously had on the field of biology, physics and chemistry. So it actually just takes the same kind of exponential rate in development as that of the force of a processor. So actually you have really a parallel between digital insight and also material output. And this is for the opening day. Just, I mean, this is not a matter of talking about just concrete, glass, wood, stone, etc. Like it's actually very much about saying what do I want material to perform like? What kind of sustainable approach? Of course, durable, interactable. How can I actually design materials to meet the needs that I have in a specific project? And I think that's interesting when materials start to like surprise you or to kind of support your design, so it come kind of symbiotic with the design development. This is Nari Oxman's monocoque, which is talking about kind of how you can design material to have different structural performances in the same material. Of course, transparent concrete. I mean, it's so low tech, but when you see it, it really moves you. So I like that. Like when material surprises you. I really like when you get into this kind of knowledge about how can material be designed. I mean, this is from North Carolina State University's Center for Nonwovens, and it just shows 3 textiles, all containing carbon particles, and having carbon inside the textile, it makes it self-cleaning. And just saying that on the left you see how they can control the process, so it's mechanically capturing the carbon, and in the middle it's a chemical solution, and at the right you have this kind of thermal where it kind of melts onto the surface of the carbon. Just saying, this is a design that we are able to control, like the surface structure. For example, when you see butterflies and beetles appear to be colorful, they're not. In reality, they are more transparent, brownish. What they do is that they have this kind of surface structure that reflects only the color of natural daylight that is intended. And that's something that we can copy or mimic. So we can create color without pigment, without chemistry. We all know the lotus leaf, how this kind of hydrophobic surface is kind of cleaning water while running off. So it's not about having a super slick surface, it's having this kind of micro architecture, this kind of bulky design as you see on the left, that kind of breaks down water ability to stick on a surface, and hence creating this self-cleaning effect. So all of this is something that actually can be applied and worked with. We have this project in Berlin next to the parliament, the Reichstag, where the project scheme were a cubic scheme, and we won with this entry, having these kind of atriums with different lookouts towards the city. Try to introduce this kind of self-cleaning facade system, but not with the hydrophobic, but with a hydrophilic approach. So actually, this means that when exposed to UV light, it's also breaking down kind of pollution from cars. So it's helping, of course, a building to be lower maintenance in terms of the self-cleaning effect, but it also purifies the air in the surrounding of the building, equivalent to almost 500 trees. So having these kind of integrated material behaviors, this is a more like passive intelligence. It's a very thin metal. It comes from the shaving technology, you know, like these old-time shavers where you had this kind of metal film. And the way you manufacture that, it's an acid process. You can kind of offset that so you actually get the holes in an angle that is what you need for solar shading. So you can do micro-perforated solar shading that you can put in between two layers of glass, having it free of maintenance and cheaper, and also having a much better quality in the view out. On the internal part, the client wants an indoor climate of 21 degrees. For that, we are working with phase-changing materials, which you might know. These are like Micronol is a product name, and it's kind of a micro spherical size, where these kind of polymer pockets has the content of paraffin that shifts its phase, like goes from solid to being liquid at 21 degrees. And doing that, it absorbs a lot of heat. So we have this in the ceiling, we have plastered ceiling where the Micronol is integrated into. So it actually becomes some kind of natural binder for all the overheat. Doing that, we are having a much smaller climate system, but also saving energy, and what is equivalent to 150 tons of CO2 in one building for integrating this material. So the 5 design strategies, the informed design, it's mainly also working internationally. We need to have an understanding of how light and energy affects the building. And as you know, in the first 10% of a design development, that is when you actually do the big decisions on volume and orientation and room depth, etc., room height. So we have developed these kind of small plugins in order to understand geographically impact, but also kind of the local context understanding, self shading design. So one example here, you see, it is pretty analog at the office. I mean, we start out doing like conceptual ideas that we test out the first week individually, and we have these kind of ongoing pin-ups. So in order to do this, I mean, these are 3 examples on plugins. Like we have this that gives insight or information on the direct sunlight on the facade. You have the direct sunlight inside, and then the diffused skylight. I mean, these are actually highly unprecise, but that's the point. We just need feedback from the first day of designing. So these are being developed to have some kind of course, an accurate feedback, but more like 50% or 60% accuracy. This example, we have this concept of a hotel or tower project in Beirut, where you see how this kind of 3-dimensional facade we're supposed to have some self-shading effect with this kind of a steep sun path of the area, and being able to try and examine that at a very, very simple design development actually gave some kind of feedback that it was plausible, that it gave a lot of energy savings that we then could go and prove in a more like sophisticated analysis software afterwards. Examples on how we work with this kind of 3-dimensional facades is a law office in Copenhagen that is has moved into this building. The concept was not just to meet the high Danish energy performance requirements, but also tries to exceed them by having this kind of sculptural solar shading. Seeing this from the south, it actually seems a pretty kind of closed building, and from the south it opens up more, or from the north, and you have the view to the ocean as well. So doing that, we worked with fiber composites. We wanted to mold the facade to get a complex shape, but also in a light structure. There was a lot of kind of development into that I won't go in details with, but it took 2 years to kind of get this kind of structural system. You see how the black underneath the travertine stone is this kind of molded facade system. Understanding the kind of geometry for that, developing new kind of floor slab designs and way to mount this. We ensured a very fast closing of the building, and also created this building that appears open from the north, but also shields itself from the sun, and also of course gives this kind of individual bay window for each of the lawyers, and creates this kind of geometrical appearance and its own aesthetics. So technology design, it's very much about trying to push what's possible, introducing new materials and production technologies. This is just an example on a facade system that we're developing together with Arab and Fiberline, among others. So the idea of this is a unitized system that is lightweight. It is built out of fiberglass, so it has very low thermal conductivity, and it also has this kind of potential transparency or translucency. And we fill it with aerogel, which is the world's lightest solid and also the best insulating material commercially available. So the idea is to actually do a facade system in half the thickness with double the performance, and having that to have these translucent potentials. And it's a part of a bigger project, so this is the first step. We kind of get the metaphorically the chassis sorted out, and this will be commercially available in a year's time, is what I've heard the last time. It's being manufactured by Permastelisa. And parallel to that, we're looking into all the add-ins or add-ons, how we can integrate different LED systems, different phase changing, different solar cells, etc. So we try to make this kind of standardized, but yet an object that you can customize yourself. Behavior design. I mean, this is to the GXN a new chapter, because today when I'm here, we have a new team member. So she's an architectural psychologist, and she's been working monitoring our projects throughout her master project. But now we are doing a PhD program together, where we are developing knowledge on how do building physics and spatial surrounding affects the human behavior in different environments, learning environments, working environments. And one of the buildings that we have had a great success with, kind of changing a culture, is this high school where the program is it's very open. You see how there are no corridors. Everything is kind of a space for use. And it's also supporting a new way of learning, where students take initiative and take kind of a lead in the way they combine the different schemes and authors, how different classes can support each other. So it's very open spatially, and actually the whole school is one open space, all tied together with this kind of spiral central stair. So you see how we kind of organize the building more like a cityscape, having kind of the central plaza. We have the different places for making homework. We have a few enclosed spaces for more like theoretical learning. So all of this is really just changing the way that you interact, and also it's now the most sought after high school in Denmark. Then green design is it's very much talking about how we can establish kind of what's called circuits, how you can work with an optics of having material coming back into new usage. This is very much inspired by Cradle to Cradle, where we are developing together with Foster+Partners the first building code on how to realize this kind of philosophy, how to actually utilize this in practice. We are also working with something that's more like just really green, and it's this project that we're spinning off now. It's called Urban Green. So we are forming a company that actually is able to sell wild plants and kind of make nature restoration inside cities to work with red listed species that are threatened in nature. And having this kind of contact to these persons, like it's greeneries, biologists, etc., also bridge to this kind of project where a client comes and say, I want to make a building that is kind of self-sufficient in food. I want it to have to be a showcase for integrating many different ways to integrate physical green components. So you have, of course, the different garden systems, inside and outside vertical walls. Also having living machines where plants are treating the internal water usage, both the gray and the black water, becoming also some kind of features inside. Having farming, this is an agricultural high school in Sweden. So they have vertical farming. They're also working with showcasing and learning different kind of hydroponics, where all the nutrients is bound in water. Having traditional what you call plant beds, aeroponics, just to kind of create a building that is also supporting kind of new knowledge on agriculture, on future farming systems, but also having a heart in the city where food is being produced to the local area, and where the building kind of flows with the public green area, so it's accessible for all people until the middle of the building and bridge over to the forest behind it. And on the inside you have dormitories combined with elderly living, and have this kind of green gardens for enjoyment, but also for food production. So the very last project is experimental design, which I said is not maybe the most overhead making category in our unit, but we need to engage to these projects where challenging ourselves are able to kind of develop answers that we then can use for later purposes. So this is a sculpture we were asked to do in intelligent and sustainable materials. So we wanted to tell how nature is rich in forms, so having sustainable materials, we really wanted to make a more like expressive answer to showing what that could be. Also how material can be recycled, how they can be resources for further purposes. And also how nature is dynamic, how you can actually harvest energy from your surroundings. So we did this kind of form finding, trying to kind of find a shape for a Möbius strip. So to jump to conclusion, this was kind of the scale and the output, 8 meter times 5 meter, what you call green sculpture. And having this kind of solid, we kind of embedded a lot of features on it, like air purifying surfaces, self-cleaning coatings. Also these piezoelectrics that you heard about in the army boots we had in the floor area called energy floor. So when people were playing on it, they were generating energy into this kind of embedded LED circuit. We had the phase changing. And we built it off kind of natural materials. Was flax, and it was cork, and it was soybean oil, and it was cornstarch. Having these wonderful manufacturing people from Yorkshire building it. Same guys that built the Chanel pavilion. And just giving them like new materials that they haven't had any experience with before to play with, and and form an understanding on how to build with this, see the process of the making. And this was when we completed the first time, and we didn't know that because we actually were in a very tight time schedule. It was the first time anything was built in that size in biocomposites. And the real innovation was really to just get it built. So it actually gave us a lot of publicity in directions we didn't control. And also we came back to this kind of huge composite fair in Paris once a year. And we had this innovation award ahead of other industries. So we were actually able to give something back. In this lineup, we were before Lamborghini and British Airways and Russian Railways. So it was really something to be able to take this kind of excitement into material potentials, and just by doing a kind of a sculptural statement, we were able to create this kind of development that we are now continuing on. We are doing a research program for 7 million euros for the next 3 years, developing new commercial components for building industry, both internal and external. And the sculpture is still standing today, and it's this kit magnet. So it was a great experience, and also I think it was a good way to show how innovation sometimes just happens without you knowing it. So that's the last slide. Thank you very much.